Okay, good morning. So today we're going to start with a fundamental chemistry lesson, which will be a bit of a recap, but we'll go over some of the most important aspects of chemistry. So we've started off here, as you can see, a diagram of an atom. You will remember, hopefully, in the middle, that's the nucleus. It has the neutrons and the protons, okay? And they compose most of the mass of your atom. So in terms of their relative mass, each of them has a mass of 1, okay? They're about the same mass as each other. But the electrons are much tinier, okay? Their mass is considered to be almost insignificant. That's about 1/1835, okay? Something like that, depending on which book you read. 1/1835. That means that if you had, say, a very microscopic weighing scale or a seesaw, and you put one proton over here, guess how many electrons you would need for it to balance out the mass of it for the same weight? You would need 1,835 electrons. Loads, okay? So electrons are tiny, okay? And they go around the nucleus. Now, why are they going around the nucleus? Well, why do planets go around the sun? There is a force of attraction between the planets and the sun, gravity. There's a force of attraction also between the electrons and the protons. So the protons have a mass, so mass of +1, but they've also got a charge, and their charge is +1. Okay? So +1, think pro, you're for something, positive, yeah? +1. Don't just write plus, write +1. Okay? It's the number is important as well, because the electron has a charge as well, but it's an opposite and equal charge. So its charge will be -1. Okay? So opposite charges attract, therefore the electrons are going around the nucleus as they are attracted to the nucleus, okay, and orbiting around it. Neutrons, I think it sounds a bit like neutral, no charge, okay? So I'll just write no charge for that bit. Okay. Now, so that's the basic overview. Remember that and that neutrons and protons are both part of the nucleus. Okay. Now you'll also remember, I'll just rub out the middle bit, that we looked at electron arrangement as well. Now, electrons, they don't just go around the nucleus in any arrangement. They are in an ordered arrangement, okay? Now, as you can imagine, it's quite, there's a smaller circle close to the nucleus, but if I was to draw another circle further out, it would be a bigger circle. Now, these circles, you might remember, in terms of atoms, we call them shells, okay? Electrons can be found in shells. How many shells can you fit? So how many electrons can you fit in each shell? Well, that rhymes, doesn't it? You can fit in the first shell 2, okay? And we often use the cross to represent the electrons, okay? Now, let's start off with the smallest atom, hydrogen. You've only got 1 electron in hydrogen, okay? So that means that it will only have 1 electron in its first shell, okay? And that's it. If you went on to the next element, helium, helium's got 2 electrons, okay? So therefore, you can put 2 electrons in that shell. Now, were you to go on to lithium, which has 3 electrons, okay, that's its nucleus for lithium, How are we going to fit them in? Would you put them all in the first shell? No, you wouldn't do that, because the first shell can only fit 2. So I put 2 in the first shell, and once that shell is completely full, I have to move on to the next shell. So therefore, lithium would have 2 in the first shell and 1 in the next shell. So for its electronic arrangement, you can draw it like this. Sometimes they draw it, or they write it like this: 2 in the first shell, 1 in the next. For helium, I would just put in 2 like that. Okay? Now, every time I have an extra electron for a different element, I have to add them in the same shell until that shell has completely filled up. Okay, so you fill up near the middle. Once that shell's filled up, you go out to the next shell. You fill it up. Now remember, it's 2 for maximum capacity in the first shell, then it's 8, then it's 8 again, and then the rest you can put in the last shell there. Okay.